we'll make two presentations. So first, I will show you a little bit the current status of the SOLARIS. I will focus explicitly on the infrastructure. Okay, so there will be no talk about the science. And actually, my presentation is just the introduction to very important presentation, which will be after by Professor Luke Pate from the Polsher Institute, who will present his results of his 3-month sabbatical stay at SOLARIS and the studies of possibilities of implementation dedicated infrastructure at the SOLARIS infrastructure dedicated or to be used by the Ukrainian society. All right, so go to my presentation. Just let me share the screen. Yes, this should do. So now I will need this one and this one. Yep. Okay, excellent. So I hope you do see slides and you do see my laser pointer. So that's right. Can I just get the confirmation? Sometimes I'm getting lost with I have two screens. So do you see?
Yes, we do. Yes,
excellent.
We do.
Thank you very much. All right. So with this presentation, I would just to say a little bit about the SOLARIS infrastructure and just to say you what actually infrastructure status we have. So SOLARIS is located in Krakow. It's actually still within the city premises, very close to the new campus of the Jagiellonian University, which is up here on this photograph. And actually on this campus, we have really over few hundreds of scientists working in the Faculty of Chemistry, Faculty of Physics, Faculty of Biology. We have also Małopolska Center of Biotechnology, so very strong scientific community located next to our facility. This has been already mentioned. We are a partner or we are complementing family. We call it Family Lips Family. We are 16 facilities as already introduced by Britta. And just the 2 slides about the accelerators. This has been already mentioned. The SOLARIS is a low energy ring. I'm not going to talk about the details here. It's just to say that we are operating 2 accelerators. So we have a linear accelerator that gives us the 600 MeV electrons. These electrons get injected into the storage ring where they get the final energy of 1.5 giga electron volts. So actually what you have here is a photograph of our ring from the top when the concrete is removed. And actually maybe what's the most important to remember or the numbers that are particular for SOLARIS is the ring circumference of 96 meters, electron energy is 1.5 giga electron volt, and we have so-called 12-fold geometry, meaning that the full cycle is made with the 12 bending magnets that are located in the storage ring. Of course, we are still using insertion devices for production of X-rays on the straight section. Now, regarding the infrastructure, actually now we have 7 beamlines into operation. I will say in the next slide more technical specifications what these beamlines can do. This is just the general view of how these beamlines are located around the storage ring. So we have on this side, we have a low energy X-ray beamlines, so soft X-ray beamlines or VUV beamlines. On this side, we have 2 beamlines that are operating the hard X-ray energy range and the series beamline that's dedicated to IR spectroscopy. Now, maybe one comment regarding the naming. I'm sure everybody knows, but just wanted to emphasize that the names of SOLARIS, it's not connected with the bus factory. Okay, so if somebody missed that, I would like to pay attention that the SOLARIS, it's not connected to the bus factory, but it's connected to Stanisław Lem, who was a great Polish writer about the science fiction essays, and he wrote this excellent novel called SOLARIS, which was translated to over 50 languages worldwide. There were several movies recorded. And actually having a facility name as SOLARIS the naming for the beamlines. We try to keep the nomenclature, meaning the acronyms are related to the science fiction area. So, for example, you may see a Pirx beamline that actually comes from the tales of the Pirx pilot, and everybody knows that the Pirx was flying to the Astra planet and so on. So we try to keep these nomenclatures just to be consistent. So we are operating around the science fiction area. So this is, Alexander, already a big challenge for you, because you have to write the proper name for the new infrastructure that eventually will come. For example, also, we are not stick explicitly to the Lem, to Stanisław Lem, because it's difficult to find all the names from his books, but we keep this science fiction area. And for example, the Siri beamline, this is something from the modern times, but you may know this is a character from the Witcher, Polish Wiedźmin, a series of fantasy novels that gives the name for the chemical imaging at the IR range. All right, so this is the actual status. Now, we do have 4 big investment projects that are coming in. So we have actually 4 stations, or 2 beamlines and 2 stations that are being built right now. So we have SMAUG and the SOLARIS beamlines, so the small angle scattering and the crystallography beamlines that are going to be built next 2-3 years. We are building a NAP XPS branch beamline around the soft X-ray energy range, and simultaneously we are also constructing an operand end station that will allow you to look on the materials at the heart X-ray energies and to look into the materials at operating conditions. We do have some projects submitted for the applications, and now coming to the heart of our workshop today, there is a place of the sector on the sector 2 on the straight section where we can construct, or we can envision, a beamline that is built within the LIPS initiative for the Ukraine. So this is a beamline that where the Ukraine can consolidate their research. And this will come, of course, later a little bit more in details with the Luke Pate presentation. Now, just to mention, we do have on our facility also the Cryomicroscope Center. We operate 2 cryomicroscopes, and we do operate, or we start to operate or bring into operation the neutron laboratory. Actually, the source, the neutron source, it's coming from the Kiev. So this is a collaboration between the Faculty of Physics and the Solaris. So we do have already some Ukrainian accents here. And just to say, this portfolio of the beamlines of the infrastructure is to be widely used by the researchers. So when you think of your projects, you don't have to focus on the single beamline. You can still think to use the other beamlines for your research projects. Now, very briefly, I'm not gonna go into details, but just to, this sets a background why we talk today about a little bit micro and nano tomography. So actually what we do operate right now, we do operate a range of the soft X-ray beamlines that provides either the spectroscopic applications, the microscopic applications, but at the soft X-ray energies, but also we do have 2 beamlines which are very complementary when we talk about the angle resolve photoelectron spectroscopy. So this is already available now on the Solaris. And what I mentioned, we are building the NAP XPS station that is dedicated actually to the XPS research at ambient pressure, also working on the soft X-ray energy range. On the hard X-ray side, we do have 2 beamlines that are operational. 1 beamline dedicated to the spectroscopic application, and the second beamline dedicated to microspectroscopic applications, but at the hard X-ray energy range. And then we have these 2 beamlines and 1 end station that are coming into operation. So the beamlines that are dedicated to the structural research, and the beamline dedicated to the chemistry application. And on top of that, we do have a IR beamline that is operational and offers 3 end stations for researchers. And then we have the cryomicroscopes that are available also for the users. So This is the portfolio. And when we make the discussions with Luke, Pate, with Alexander, when we look on the portfolio of the methods that we have actually on the synchrotron, we found out that's what we are missing, and where is the power of the SOLARIS is the nano spectroscopy or the microspectroscopy at tender X-ray energy range. As we all know, this range, it's not really well explored. It's a little bit difficult to be explored because you need a little bit of vacuum conditions. You can work purely in the ambient environment. So it's technically challenging, but on the other hand, it offers great opportunities, and the research on the materials which are very important for many research fields like sulfur, phosphorus, potassium, and so on. So this is where we got. So we try to have at the SOLARIS a range of the methods that provides the scientists research, complementary research in different research areas. Actually, what we intend to offer, it's not particularly different to the other synchrotrons. I think every synchrotron at the end has very similar portfolio of research methods, but actually where we get and what we found it's really missing, it's a dedicated nanospectroscopy beamline that can be built within our collaboration within the LIBS or under the LIBS umbrella. And this could be called Ukrainian beamlines actually at SOLARIS built within our consortium. We don't have for the moment a concept, we don't have a funds yet, but this I think we can organize. We do have some very nice, maybe not yet decide or not yet finalized in-kind contributions, but we think that Polsher Institute, at least there are signals we'll see from Luke Pate how far it gets. We have a signals that some of the equipment can be already donated for the beamline. The rest, of course, we can find through all the projects or to joining the projects that Britta mentioned. There is so many activities that I'm sure we can find the dedicated funds to complement this project. So with that, I would like to finish. I would like to thank you for your attention and very smoothly move to presentation